In this video, we're going to be talking about production reliability checklist for AI agents, automations, integrations, and backend systems before they go live to production. Before we dive into the checklist, it's important to mention that production ready means controlled failure. The goal is not to pretend the system will never fail. The goal is to make failures visible, recoverable, and limited in damage. Essentially, you have this life cycle. First, you detect what happened, and you contain, and you stop the spread, and you recover from that incident, and you able to review, meaning escalate to human when needed, for example, and improve and learn from that incident. That's a basic life cycle of a production system. You need to be able to have these abilities. Now, the first item in our checklist is dependency map. This allows you to list every external service, API, database, queue, model, webhook, and human handoff your workflow depends on. It doesn't have to be complicated. It can be a simple map of what your system needs in order to complete a task. And that also allows you to see the dependencies. And then you can see where it can fail, where it can break. For example, if your system, your agent, for example, depends on a CRM, external CRM, or Stripe, for example, for payment processing, then your Stripe goes down or the CRM goes down, that your system is not going to be able to complete that task. And then from there, you know you have to implement a mechanism to handle that. Number 2 in our checklist, error handling. Having a proper error handling is super important in any production system. Doesn't matter if you're using no code, low code, or custom code. You need to be able to catch any type of errors that happens in your system and handle properly. Essentially, error handling is a planned response for validation errors, API failures, model failures, and bad input. It's very important because the last thing you want is unclear errors, because it creates invisible data loss and hard to debug behavior. So whenever an error occurs in your system, it needs to be caught, it needs to be logged properly, so you can go back, your technical staff can go back and see exactly what happened. So a quick exercise you can do right now is check if every failed step produces a clear status and next action in your system. Checklist number 3, timeouts. Very important. No external call, model call, workflow step, or queue should wait forever. A maximum allowed wait time for a step before the system treats it as failed. So, for example, you're making API calls to the CRM, to Stripe, for example, to PayPal, whatever API system you're using, or OpenAI, for example. You should not allow that API call to take 5 minutes, for example, because you expect that a quick API call should return a response in milliseconds, right? So you should not allow the operation to run for 5 minutes. That's definitely something's wrong. So you set up timeouts, meaning this operation should stay alive for maximum 3 seconds, for example. This one, 5 minutes, because it's a long running task. So for each type of operation, you determine how long they should run, and that's achieved with timeouts. So you have to ask yourself, are timeout limits set by operation type and business risk? That's the question you have to ask to check if your system will be reliable in production. Number 4 in our checklist, retries and backup. Very important. When something fails, for example, you make, again, I'm going to use the API call over and over because it's the most simple example that we could use in terms of relying on external systems. Let's say, for example, you made an API call to Claude or to OpenAI, and it fails. A production-ready system will not give up at first try. It's going to retry again, for example, 3 times. And usually in production, you use exponential backup, meaning first time it fails, you wait 2 seconds, for example, you try again. And then if it fails again, you wait 4 seconds, and then you try again, and then 8 seconds, etc., etc. And then after the 3 retries, for example, you send it somewhere where a human or a member of your technical staff can go and review that transaction. And we're going to talk in a little bit about dead letter queue, which is where you're going to be sending transactions that fail the retries. It's very important to have the retries. You should never give up at first, because sometimes systems go down due to network error or something else, a temporary failure. Of course, not all first is worth retrying, because, for example, if you send an API call to OpenAI and OpenAI responds back like, oh, the API key is invalid, you're not going to try again because it's not going to work. So only certain type of errors it's worth retrying. And a quick question you have to ask right now is, in your system, are retries limited, delayed, logged, and safe to repeat? Number 5 in our checklist, idempotency and deduplication. Repeating the same event should not create charges, records, emails, or agent actions. Let's say, for example, you have your system receives payment through Stripe, and Stripe has this webhook that notifies your system that someone paid. If you don't have this idempotency in the duplication mechanism, if Stripe sends twice a webhook notification, your system is going to record twice that a customer paid twice, which is not true. And that's a very dangerous thing. So it's important that each transaction in your system has have a unique key that identifies the transaction. So if Stripe sends, doesn't matter how many times Stripe, for example, or any other external system send that transaction back to your system, you will use that key to identify that specific transaction and know if it was processed or not. If it was processed, you ignore, so you don't create another record, duplicate the records. It's very important. And you have to ask yourself if each important operation have a unique idempotency key in your system. And again, this goes with the retries and webhook replace, because for them, if you retry an operation, right, it's important that you don't retry like a new transaction. It's important that you have this identifier that know like this is the same transaction that I tried 4 seconds ago that I'm going to retry again, so you don't create duplications. Number 6 in our checklist, dead letter queue. This is where you're going to send jobs that didn't complete after all the retries. Let's say you retried 3 times and didn't work. You made the API call to OpenAI or Cloud, it didn't work 3 times. Then you send that transaction to that dead letter queue. Essentially, is a record in a database, most likely, where it's going to stay there waiting for review. Because if after 3 times OpenAI is not responding, then someone needs to step in, most likely, to see what's going on. And the main goal of that letter queue is not to lose the transactions. Because if you just retry after 3 retries and you don't store that thing, that transaction, then you're going to lose it. For example, if you capturing like a lead came through your contact form in your website and came through your agent, and then the agent wasn't able to create that lead in the CRM, you don't want to lose that lead. If the CRM system is down, you need a way that that lead stays somewhere safe and someone can step in and see what's going on, why it wasn't added to the CRM. And a quick exercise you can do for this checklist item is ask yourself, can failed jobs be inspected, corrected, and replayed safely? Number 7 in our checklist, circuit breaker. When a dependency is failing, the system should stop calling it for a period of time instead of making the incident worse. Meaning, again, just go with a retry, right? Let's say you're making this API call to your CRM 3 times, it didn't work. And then you realize that after a couple of tries with different transactions, it's not working. So you realize the system must be able to realize nothing is working for a certain period of time. So let's stop sending requests. So you don't send more requests to that system. What you're going to do, you're going to stop sending requests for a period of time. And then during that period of time, let's say for 10 minutes, you prevent your system from sending any requests to your CRM. And then during the 10 minutes, every minute you send 1 request, for example, just to test if the CRM is up. If the CRM is up, then you can send the other ones, all the pending requests. If it's not, then you just keep sending that 1 request to probe to see if it's up. And the concept that came from electrical engineering. If you see in your home, you have this electrical board and you have the circuit breaker, which usually it trips every time there's a surging in the current and something like that. And you can go and turn that back on so the electricity flows in your home again. So it's kind of a similar idea. So it's like you turn the circuit off until the system, the external system, is back up, and then you turn that on so all pending requests flows through your system back and sent to the external system. And the quick question you can ask yourself right now is, does the system degrade gracefully when a critical service fails? The answer to this should be yes. Checklist number 8, rate limits and back pressure. The system needs a way to slow down when demand or dependency limits exceed safe capacity. If you see, when you're an API that you connect to OpenAI, Cloud, Stripe, they rate limit you. If you send too many requests within 1 second or 1 minute, whatever the policies are, they're going to rate limit you. They're going to return a 429 rate limit error. And the same you should do for your system. If you're building a system that receives information from external system, you want to make sure that you rate the limit so they don't flood you. For example, if you receive webhook notifications, right, from Stripe or any other external system, you want to make sure that they cannot send 1,000 requests in 1 second to your system, because then they're going to overload your server, it's going to bring your system down. So whatever system is connected to yours, you should be able to rate limit them. Hey, you can only send 100 requests within 1 minute, for example. If you send more than 100 requests, I'm going to rate the limit. I'm going to block you for certain time so you don't overload my server. The same they do to you, the external system do to you, you should be able to do also with any other external system that sends information to your system. And the quick exercise is to check if the system can queue, slow, reject, or prioritize work under pressure. Well, another thing that I really didn't mention is you need to be, for example, to be able to have a way that if you're under pressure, you can queue some of the work and not try to execute them all at once because maybe your server is running out of memory or CPU capacity. So you can probably put them in a queue and then execute them asynchronously over time and slowly as resources are available, and then you execute them instead of trying to execute everything at once. That's a very important thing to have in mind. Number 9, stage checkpointing and recovery. Long-running workflows and agents need to know what already happened and where to resume. Meaning, if you have your system has a lot of your operation has multi steps, for example. They go through one system, they get one information, then they send to the other, and then with a goal in the end to produce a report, for example, or a certain outcome. Let's say, for example, your system produce a report, for example, just an example. Your system or AI agent goes through 5 steps. And when they got to the 4th step, they executed, the agent got information it needs. And then when trying to connect to the last system, it failed. In that case, your system needs to be able to track that your agent was able to go until step 4 and it failed on step 5. This way, it doesn't have to go through all the steps again because there's a waste of resource and also of money. Because, for example, if you're using AI agent is using tokens to any, it consumed tokens until step 4. So you paid money for that transaction already. If it fails there and you want to resume that operation, again, using, for example, that ladder queue, retries, you shouldn't spend that money again, going back from step 1 and connecting to OpenAI, spending tokens, and then going back. That's now you should keep track of the state, what information it has available, and resume from there. So, simple question you ask yourself right now is, can interrupted work resume from the correct step? The answer should be yes. Number 10 in our checklist, observability and others, very important. You gotta have observability, a visibility layer on what's going on in the system, because a lot of the operations, they happen on the background. For example, if your agent is making an API call, you need a way to see that call, that transaction. And that is done with observability. You need an observability layer, like a user interface, where, for example, you have a record table with all the transactions, all the API calls that were made by the AI agents. What was the result of the API call? How many tokens were spent in that call? What was the output, etc. And also alerts. If, for example, you made the API call and several times it didn't work, then you alert someone, for example, you send a text message or Slack message, for example, hey, to the technical staff, for example, hey, try 5 times to create this lead in the CRM, it didn't work, can you check it out? And because they have the observability layer, your technical staff can always go and see what happened. He got his information, tried to connect to CRM, and the CRM was down temporarily. So you have full visibility over failures, latency costs, throughput, and any unusual behavior. And the question you have to ask yourself for now, if something happens, can you answer what happened, why, and who was affected? If you can, then you have enough observability and alert in place. Number 11 in our checklist, human review and escalation. That in any system, we need that mainly when running AI systems, because certain things you wouldn't trust to AI. For example, if you're doing sensitive financial transaction and producing financial reports, you might want to let human have the last word in terms of the output. You can have the AI help you, but you gotta have a human verify, because if AI makes a mistake, hallucinates, and gives a wrong number, that can have huge impact in the business, and you will become liable because you gave the wrong information to the client. So that's very important. And whatever tasks that can create liabilities, it requires human judgment. We should have a human in the loop, and we have a clear path in the system, in the workflow design to escalate to the human, non-negotiable. You're not gonna let the agent decide, oh, I wanna give that to you. You gotta have a system in place to say, if the subject or the request is this type, is legal or financial, stop, send to the human, non-negotiable. And of course, what you need to do, quick exercise right now, is check the escalation rules for low confidence and high impact actions in your system. Number 12 in our checklist, governance and audit trail. Very important, having a governance system in your system, agentic system, because you need records of decisions, approvals, input, outputs, and changes. So essentially, governance is a bunch of policies that shows who did what, which data and model, what should happen if something happens, who's responsible, to whom this should be escalated. There's a bunch of operating procedures that you have in place to make sure that if something happens in production, you can recover quickly, right? You have already outlined the steps that anyone in your team can follow to bring the system back up or address that specific issue. For example, you can have a policy, a governance policy for a record. A lead came from our website and didn't land the CRM. Are the steps that our technical staff needs to look at, or our operational staff needs to look at to see what happened? And once they find what happened, what change should be made? And if they make those change, what should happen after they make those changes? So everything off the line, so there's no confusion. And that's very important for production system, because then you have this uniform, this plain way of handling incidents in your company. So a quick question you can ask yourself is, can you trace an output back to the input, prompt, model, and approver? And you need to know exactly what happened. That goes with the logging, error handling, retries, everything. Number 13, security, secrets, and access management. Any system should only have the permission it needs, and sensitive keys should never live in a safe place. So for example, let's say you have an AI agent that connects to your Stripe account. Most likely you don't want the AI agent to transfer funds or make those sensitive operations, right? So if you need your AI agent to get an idea of your balance, how much you have in Stripe, you can give it an API key with read-only permission. This way, even if someone gets access to that key, they will not be able to transfer funds out of your account, because that key has minimum permission, just read-only permission. That's the importance of giving the least privilege to your API keys to any entities in your system. And make sure you also, from time to time, you update those keys, you change, you rotate them, like after a certain period. And that's part of, for example, your governance, your policies. You can have this internal procedure that say, hey, every month or whatever, just change the API keys, or whenever an incident happens, make sure you rotate that API key and delete all the old API keys, things like that. And you need to make sure the API key is never added to the code. A lot of folks sometimes, the normal known procedure is to add the API key to the env file, the environment file, the .env file usually. And that's better than putting the code, but there's still a risk in here, because if you make a backup of your full server, of your web directory, it will take the env file, and if that backup falls in the wrong hand, they're going to have access to everything. So ideally, if the system you use has a secret management, like you're using AWS, Supabase, those cloud systems, usually they have a way to put a key outside of your code, your system web directory, and as an environment variable, instead of adding to env file or whatever, you put that, they have an interface where you can add your key. So that's the idea. But if not, you can use the env file, but make sure if you make any backup that is well protected, so the files, the credentials in the env file, someone gets access to the backup, they don't steal the credentials. Number 14 in the list, data validation and guardrails. Very important. If you have a contact form, for example, in your website, and you expect that in certain field, you expect them to enter their email, they should not be able to provide something else. Maybe they will not provide their email, you cannot force that, but they should not be able to enter numbers, for example, in that field. And you need to validate that input before you send that to your agent or down your workflow. So that data validation is very important. Some fields are required, so you should not allow to submit the form until they fill out those fields. And guardrails is very important, mainly for AI systems, because again, if you have an AI agent providing customer support, you do not want that agent giving legal advice, for example. So you got to have guardrails in place, for example, that says, hey, never give legal advice. Or if they ask for financial information, escalate to a human, transfer to a human, things like that. So a quick question that you can ask yourself is, are critical fields validated before writes, emails, reports, or decisions? Very important. Number 15 in our list, testing, deployment, and rollback. Very important. Essentially, a production-ready system needs a safe path to change it without breaking live operations. Let's say, for example, you launch your production system with 10 features, and now you're working on a new feature. It's important that this new feature, once you release this new feature, it doesn't break the previous features. So you need this test case for the previous features that you implement, and make sure those tests, they pass, which is regression testing. You need to make sure that those 10 features, previous 10 features, they pass. When you run those tests, it pass, meaning this new feature that you implemented didn't break the previous feature. That's very important, because you have no idea how many systems break in production just because a new feature was added and it wasn't tested properly. They didn't do the regression testing to check if that feature affect any part of the previous feature. So it's very important, and you need a way to be able to roll back. For example, let's say in eventuality it happens, somehow you slip through the cracks, and you release that a new feature in production, and you need a way if it happens and it breaks the system. You need to have a button or a quick command you can run to roll back to the previous version, which is easier with version control. For example, if you're using GitHub Bitbucket, you can always undo the commit once you publish that change to the production, and you can roll back easily. You need to have that in place so it's easy and smooth. It shouldn't take a long time for you to recover if you break the system after you release a new feature. So again, the question you need to ask yourself to see if your system is production ready is, can you test safely and roll back quickly if behavior changes? And that was the last item in our checklist, but that doesn't mean very important testing, having a way to roll back. That's super important. As a wrap up for today, I want to say a production ready agent has boundaries. It knows what to do when things fail, when to stop, when to retry, when to ask for help, and how to recover. You need visibility to see what happened. You need to be able to recover from something that failed safely, and it needs to be controlled. You don't want any failure to spread across your system and affect other systems. You need auditability. You need to be able to have a log of everything that happens so you can explain when something happens in the system. And that's the main difference between a demo and a system you can trust in production. Hopefully this video was useful, and feel free to comment down below anything that you think I missed or anything specific you want me to talk about in next videos. Appreciate you guys taking the time to watch this video, and I'll see you in the next one.